Hello everyone. On this video we will be going over how to identify a one-to-one function. Okay. Now that's different than just identifying a function. A function and a one-to-one function are two different things. Alright, so first we're going to do a quick review over what a definition of a function is. Remember, this is just a regular function. Okay, so remember, a function is described when every x value, or in some cases it's the input, has exactly exactly one y value or output. Okay, so let's do a couple of examples. Okay, so determine if the following are functions. Okay, so let's say for problem A, you have the set of ordered pairs. You have 1, 3. You have the ordered pair 2, 5. You have the ordered pair 7, 5. You have the ordered pair 3, 4. And you have the ordered pair 4, 8. And let's say for problem B, we have the ordered pair, let's say 2, 7. Let's say we have 3, 4. We have 1, 8. We have 2, 5. And we have 4, 1. Okay, so you want to know using this definition of just a function. This is not a one-to-one function. This is just your plain old, ordinary, everyday run-of-the-mill function. Okay, so we want to know if the following are functions. Okay, so let's start off with problem A. Okay, so if we look at problem A, remember every x value has to have exactly one y value. Okay, so these are your x values here. You have your 1, your 2, your 7, your 3, and your 4. Okay, so when x equals 1, has only one y value, and that's y equals 3. Okay, x equals 2, you only have one y value, that's y equals 5. Okay, when x equals 7, you only have one y value, that's 5. Okay, you don't see x equals 7 anywhere else. When x equals 3, you have one y value, and that's 4. You don't see x equals 3 anywhere else. Okay, when x is equal to 4, you have only one y value, that's an 8. Okay, so these are all your x values here. And your y value, only have one y value each. Okay, so you see there that a is a function. It's a function since every x has exactly one y. Okay, every x has one y. Okay, so let's look at b. Again, these are your x components. You have x, 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 and your x. Okay, here you have x equals 2 has y equals 7. But, this is where it gets interesting. Here, x equals 2 has a y equals 5. Okay, so x equals 2 can't have a y that's a 7 and a y that's a 5. Okay, so we know that this is not a function. Since x equals 2 has more than one y value. And that's your y equals 7. Oops, sorry about that. Remember to look up at the screen, and y equals 5. Okay. Now notice one thing with A. If you look at A, each x has to have only one y, but the y values can match. You notice here, you have y equals 5 here and y equals 5 there. That's perfectly okay if you're looking for a function. Okay, you can have more than one y value. Because remember, the definition only says every x has one y. It doesn't say every y has one x. Okay, so let's look at another example of a function. Okay, so if you're still writing, feel free to press pause. Alrighty, so let's say for this example, if you have, let's say 1, 2, 3, 4, this is your input. And let's say here you have A, B, C, D. That's your output. Okay. And you want to find out, let's say that 1, let's say that goes to A. Say 2, that goes to B. Say 3 goes to C. And also 3 goes to D. Okay. Now, does this graph represent a function? Okay. Now, remember, your input, that's kind of like your x values. Your output, those are your y values. Okay. So, to be a function, each x can only have one y value. So, remember, x equals 1 has a y value of a. X equals 2 has a y value of b, or an output of b. X equals 3 has a y value of c, but x equals 3 also has a y value of d. So each of these x's can only have one y. X equals 3 has two y values, c and d. Okay, so this is not a function. Not a function, since the input 3 has more than one output. Okay, now if you had 3 goes to C or 3 goes to D and 4 goes to C, you would have been okay. But because 3 has more than one output, it's not a function. All right. right, so hopefully that review kind of brought back some fond memories of functions. But now we're going to look at the definition of a one-to-one function. All right, so if you're still writing, by all means, feel free to press pause. All right, let's go ahead and start on a one-to-one function. Okay, so now we're looking at the definition. A function is defined as one-to-one if each x value or your input, in some cases, has only one y value or output, and here's the kicker, and each y value has exactly one x value. Okay, so that's the difference between a function and a one-to-one function. If it was just a regular function, you just need its top half to be true. But with a one-to-one function, both of these have to be true. All right, so let's look at a couple of examples. Okay, so let's say, for example, if we want to determine if each function is one-to-one. Kind of ran out of room a little bit at the end, but we're okay. Okay, so for A, we have 6, 2 for our first order pair. Say 5, 4. Say -1, 0. And 7, 3. For B, what if we have, we say 3, 9 as our point. Say -4, 2. Say -3, 9. And 0, 0. And let's say for problem C, we mix it up a little bit. Okay. We have our input. Okay, so let's say your input will represent ages. Okay, so let's say first you have 18 through 24. Say 25 through 34. Say 35 through 44. Let's say 45 through 54. Say 55 through 64. And let's say over 60. Okay, that's our input. Let's say for our output, let's say this is your average number of text messages per day. Okay, for each age group. Okay, so what if we have 50? What if we have 20? And 10? And 6? And let's say if we have 2. Okay, so we have our input and our output. Feel free to pause if you have to continue writing to catch up. Okay, so let's say the 18 through 24 goes to 50. Say the 25 through 34, that goes to 20. Say 35 to 44 goes to 10. Say 45 to 54, that goes to 2. Say 55 to 64, that goes to 6. And let's say the over 60 crowd also goes to 2. Okay, so let's look at each one of these individually. Okay, so first let's look at all the x values for A. Okay, x, 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 x values. Okay, so x equals 6. You don't see x equals 6 have any different y values, so you're good. X equals 5. You don't see x equals 5 from the other y values. X equals -1, same thing. You don't see x equals -1 with a different y value. X equals 7. You don't see x equals 7 with a different y value. But since we're looking for one-to-one, we also have to look at the y values. Okay, so y equals 2. Y equals 2 only has an x equals 6. You don't see y equals 2 anywhere else. So we're good with the 2. What about y equals 4? Y equals 4 just has an x that's equal to 5. So you don't see y equals 4 anywhere else. What about y equals 0? You don't see y equals 0 anywhere else. Kind of separate this a little bit, so probably could have given it a little more room. Okay, same thing with y equals 3. You don't see y equals 3 anywhere else with a different x value. So this is actually one-to-one. Okay, so A is one-to-one. Okay, so what about B? We do the exact same thing. We look at our x values. Okay, so you have x equals 3 has a y value of 9. X equals -4 has a y value of 2. X equals -3 has a y value of 9. You don't see -3, x equals -3 anywhere else. X equals 0 has a y value of 0. You don't see x equals 0 anywhere else. Now let's look at the y values. Okay, so y equals 9 has an x value of 3. But if you notice here, y equals 9 has an x value of -3. Okay, now we see that it's a function because all the x values have one y value. But it's just not a one-to-one function because the y value of 9 has 2 different x values. So it's a function, just not a one-to-one function. A function, just not one-to-one. All right. Okay, hopefully those two kind of made sense. So this one is one-to-one function. B is not a one-to-one function. Okay, let's look at C. Okay. again, we look at all of our x. Remember, your input represents your x values. Your output represents your y. So you can see here, each x has one y. You have one arrow going out of each section. So each x has one y. But if you look at those arrows the other way, this y has one x, 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 but your output, or your y equals 2, your output has 2 inputs. Okay? So this actually represents a function, just like B. It's a function, it's just not a one-to-one function. Okay? So C is a function, just not a one-to-one function. Okay, so there is a difference between being a function and being a one-to-one function. Okay, being a one-to-one function means you have to watch those y values. All right, so now, if you're still writing, feel free to press pause. But we're going to look at a way to tell if it's a one-to-one function using what we call the horizontal line test. Okay. Now you may remember the vertical line test. The vertical line test shows if it's a function. The horizontal line test shows if it's a one-to-one function. Okay, so you have two different tests. Same idea, somewhat, but the two different tests have different functions, different purposes. Okay, so let's write out the definition. If any horizontal line intersects a graph of a function, at most once. Okay, that's the key there. That means if you draw a horizontal line, if it only crosses the graph no more than one time, then the function is one-to-one, or then the graph is one-to-one. Okay, that means you draw a horizontal line, it cannot cross that graph more than one time. So at most, it's going to cross it once. Okay, and quick little note, the vertical line test only shows that the graph is a function. Okay, vertical line test does not show one-to-one, just that it's a function. All right, so let's go ahead and bring up a couple of graphs. Okay, I printed these up. Okay, so what we're going to do is we're going to see if these three graphs pass the horizontal line test. Okay, so if you draw a horizontal line here, it only crosses the graph once. You draw one here, it only crosses that graph once. So we're good. But the minute you draw one here, you see that one line crosses the graph more than once. It only takes one. It doesn't mean every horizontal line has to cross it more than once. It only takes one horizontal line to cross that graph more than once. it's not a 1-to-1 function. Now, the thing is, if you did the vertical line test, it would be it's a function. It's just not a 1-to-1 function, because it would pass the vertical line test no problem. Okay, so now we look at the next graph. Again, if we drew a horizontal line, it only crosses the graph once. Same thing here, it only crosses the graph once. Same thing here, it would only cross it once. Okay, so this one is a 1-to-1 function. Okay, so kind of look at the third graph and see if you can figure out whether or not it's 1-to-1 or not. Okay, so if you said it's not a 1-to-1 function, you would be correct, because if you draw a horizontal line, that one horizontal line will cross that graph in more than one spot. So it's not a 1-to-1 function. All right, so that is how you would use your horizontal line test. All right, so hopefully this video made sense and kind of broke down the difference between a function and a 1-to-1 function. All right, and I will see you on the next video.